I've seen people doing that at like the outdoor park gyms and whatnot.
Yeah, I mean, Bulgarian split squats are like amazing. Like I don't think any exercise hits me so immediately in the butt as a Bulgarian split squat.
That's where you got your nice ass from, hey?
Hey, you got to get it somehow. You can't be,
you don't just walk into it.
You don't just walk into this, all right? The bar for CEOs, as far as bod, has gone up. I mean, if you look at, you used to be able to be a nerd CEO and you could...
Steve Ballmer,
Exactly, yeah. And now you used to be able to wear khakis to work.
Yeah, I mean... No, it's the CEO glow up is real, but it seems to be once you actually have the money to look after yourself.
I think it is. Yeah, suddenly your hair grows back. You look young. You somehow get curls. That's what people are talking about. How Mark Zuckerberg had this like flat hair, and then all of a sudden it's like permed and curly and beautiful, like he's 17 or something. It's crazy.
Yeah,
it's crazy, but.
The cost of beauty, hey?
How much do you think investors like subconsciously like think about this? Like they look at you and they go, this guy kind of gives me that Zuckerberg or that Elon vibe. You know what I mean?
What, they're a scrawny little 19-year-old nerd, but at 45 they'll be jacked and you wouldn't want to fight them.
So I wonder about it because I don't know if like being really fit is a positive or a negative signal. Because the truth is, I don't know anybody who grinds, like who is nonstop grinding, who is also really good at taking, I mean, maybe a couple people. There are a couple people, right? Yeah. But I feel like I feel like a lot of people who are in it, they are focused on nothing else. They wake up, they don't go to the gym, they go on their laptop, right?
Yeah, I know. And the other thing is for me personally, so I've oscillated of various levels of fit over my life. And so when I lived in Germany, I cycled, it was about 30 kilometers, 20 miles each way to work.
Oh, wow.
Like 3 or 4 days a week.
Wow.
And I do this like pretty fast too. By the end of it, I think my record was like 48 minutes or something home.
Did you feel really fit when you were doing that?
I was super fit. I was like flying. I had 2 lunches every day because I was starving. I was like, oh God, I feel good.
Cycling is so good too.
Yeah, good. I love it. But the thing is, so when you climb up, you feel fantastic, but it is to some degree a higher cliff to fall off. Because then I moved to the States, and it's hard to move country partially because you're like, now what do I do? Particularly if you're a cyclist or whatever, and it's not a cycling place, you don't have a bike, whatever it is.
Yeah.
And I was like, I feel like crap, and I'm really dumb all of a sudden. I go get my blood pumping, so I started running and all sorts of other bits and pieces. But God, if you're good and then you stop. Like terrible.
Yeah. Tonal is pretty harsh to me about this. Yeah, because it computes a strength score, and very objectively that you have declined.
Oh.
Like my strength score, I was trying to break 1,000, which like isn't that remarkable, but to put it in like to give it perspective, I think of it as probably like 8 reps of a 250-pound deadlift or something like that.
Okay.
Something like that. So.
Okay. Yep.
And I was like trying to break this strength score of 1,000.
Yeah.
And I got to like 960, 970, and then I stopped for a couple months, and now I'm at 900. I'm struggling to break 900.
So I'm curious, what did you start at when you got the tonal?
So I don't think it's accurate because you get I think they do this somewhat intentionally, and I don't actually mind it, but you do start a little bit low, even though they test you.
Yeah.
And that you can make up all these reasons like, well, we don't want to like give you too much weight too soon, of course, like more data before we give you unsafe amounts of weight.
And they also want to keep you on the up so you feel good.
And honestly, it is very motivating to be on the up, and it does slow down.
Yeah.
Even if you're not using the tonal, right? In any case. But I think I started 700, and then I quickly got to like 800, 850. Okay. So it is a grind to get.
That makes sense.
Yeah.
So what's your gradient? Like how many points per week do you end up climbing? Or like month or whatever?
Yeah, I would say at this point, 1 to 5 is pretty good if I'm doing like 3 workouts a week. Yeah.
105 points per week.
Or 1 to 5 points. Yeah.
1 to 5 points, yeah.
The thing is I do miss weeks. I do like fall off a lot. So for me, it's not so, like you can see where I fall off.
And if you do those 1 to 5 points, or say it's a 5-point week, you're doing super well. Is that working out 3-4 days a week? Like, how much is that?
Yeah, it's probably like 4. I would say 4 or 5. Yeah, if you do more than 4, it's tricky. And is something else I should say about strength 4 to give people perspective is it is somehow on a bell curve how they do it. Like, I think it's almost like it was like this, and then everybody got stronger. But 1% of people would be above 1,000, or 1% of men would be above a 1,000, or something like that.
So you're jacked then.
Who use tonal? So, so we're talking about like 50-year-olds, and then that actually went down as people got stronger. So now it's like 2%, and they don't want that scale to change. So, yeah, whenever you do a bell curve thing, you gotta have this problem. People optimize the bell curve, all of a sudden it changes,
and then everyone gets swole, and oh no,
oh no, we got all these strong people. Yeah. What were we talking about before this?
Well, you asked. So we were talking actually about the VCs optimizing around fit CEOs.
Right.
Do they or do they not?
Right. I think it's a little bit of a negative. You know, maybe this has always been there, but there's this kind of rise of this like kind of like very bro-y CEO.
Yeah.
And like,
I think it's an embrace of the bro-y CEO.
It's an embrace of the bro-y CEO. A lot of things seem to be reversing culturally right now.
Yeah.
But the kind of bro-y CEO is good. And like there's more. Yeah. And
it's in.
It's more popular. Yeah. People are more open about it. But you can take that too far. And I think a lot of people are starting to take it into the red, right? Like,
the CEOs who deadlift ETF. Have you seen that?
Deadlift ETF?
Yeah, no. I thought this was an ETF. It actually might have just been a list.
I know what you're talking about. Yeah. Go ahead.
Someone made this ETF. Or was it at the very least a list of companies?
Yeah, it was like a spreadsheet. So you invest in all the companies where the CEO deadlifts.
Yeah, and it had significantly outperformed the market consistently for the last like 5 years.
Yeah,
so something like that, right? And so you really just need like the gym records of all the CEOs. And I think my theory is that this might just be for, let's say, maybe post-Series A companies. Because as you're talking about, the grind before then is just like...
It's crazy.
Fight or flight. I'm not sure about that because I've started taking better care of myself and my productivity started going up by some metrics and down by others. And so I'm trying to work out what that actually really precisely looks like and how to dial it in.
Yeah. The whole like don't die thesis is like you can live your best life with a great body. Like those things can go together.
They should go together. Right?
They should go together. But at the same time, they say things like you are a professional sleep athlete. And I have deadlines where, it's a demo the next day or it's a conference and I'm driving back and it's going to be pretty late. So I kind of believe in both. I want to believe in it a lot. Like, and I hope the world forms around it where you can you can be really healthy. But the thing is like, this is where it falls apart is like, it's hard for me in points in my life, it's hard to like wake up and get out of bed in the morning.
Yeah.
And like, you can like work on your body to get there, but sometimes like sometimes you just have to wake up early, even if you didn't sleep enough so that you show up to work on time so that you're in the habit, right?
Yeah.
So it's almost like you have to hurt your body in just the shortest of terms.
Yes. Habits matter.
Yeah.
Habits really matter. And getting to work early for me is earlier, at least at the very like consistently, not late. Because, Silicon Valley software engineers particularly, it's not weird to get into work at 10 a.m. And I think that's a really bad thing for at least myself. And I try make it for the people around me too.
Yeah.
Because if you get up, see the problem is with the late get up is the reason people like it is not always, but typically because they want to wake up late. And that is dangerous because the ideal case is that you get up actually reasonably early, like 6 or 6:30. You go do some exercise, you make yourself a good breakfast with a lot of protein, and then you go to work.
Yeah.
And then you feel bloody brilliant, right?
Yeah.
And you're super productive, you're super energetic, and then you do it again in the evening because if you're cycling, you commute home again, you get another burst of energy, and you're good to go, right?
Yeah.
That's like the healthiest I've ever been with my life is that routine.
Yeah.
And I loved it, right? And I think trying to encourage or having an early enough schedule, I don't know, like 9 a.m., it's not ridiculous, right? 8:30, that encourages like this, it's not just a mosey on in, but you still have a time before if you bother to wake up.
Yeah.
That's the right answer, my opinion.
No, for sure. I there's people who, I mean, I just feel like when I'm forced to get up, I'm not going to have as good of a day.
Yeah.
When I choose to get up, it's different.
Yes.
And usually if you're waking up at like 9 or 10, you're probably like, you probably have like a meeting or a stand-up you have to get to. And so you're really forcing yourself to get to that meeting.
Yep.
And anything you force yourself to do, you're probably not going to love.
No.
So like, yeah, it's just better to like make it a habit, make it like the most pleasant thing to do.
Yeah. Or for a little while there, and I need to start doing it to myself again, but I made a rule for myself that I was going to get up immediately when I woke up. So like open your eyes, like, you know, you look over at the clock to check that it's not like whatever, 3 a.m. But as soon as it's like past, I think I said 6. As soon as it's past 6, then you just immediately roll out of bed and get up. Because if you stay lying, you set the tone for the day.
Yeah. So this is bad, but all right, there are 2 things that get me out of bed. Okay. One
Ice
is
cream.
just right next to my bed. I feel for it. Just shove it into my face. 2 things that get me out of bed. One is the 8 Sleep heat alarm because it makes it uncomfortable to be in bed. So another 8 Sleep plug. The second thing is people in India. They do PRs in the morning to TS circuit. And nothing wakes me up faster than seeing seeing a comment, and like the brain just or seeing the code, and my brain starts going.
That's
and
wrong.
It's like, it's either like that's wrong or that's exciting, or I start writing the comment. And nothing gets me going like that. I hired out of Ukraine, same thing. That made me get up early. In my life, that has always been the trigger for waking up earlier and earlier. Nothing is. It also like. It's bad in a lot of ways because it's reactive, but it kind of like makes me excited to, like excited, not necessarily in a positive sense, but like I'm ready to work for sure. I'm thinking about work now, which a lot of people probably don't like, but I like my work right now.
We're like almost by definition weird people, so that's okay.
Yes, that's true. That's true.
But okay, so have you ever done a triathlon or a marathon or that type of thing?
I have done a half marathon, which I finished. I completed it. So yeah,
congratulations.
I didn't just start.
Cheers to that.
Thank you. It was tough.
Yeah, no, it is. I've run one casually with some friends. It wasn't like an organized event once, and I was running
a whole marathon or
a half specifically.
A half, yeah.
And it was fine. We just picked a random Sunday morning and did it because
that's awesome.
We ran together just like a bunch already, so it was like pretty easy to.
Is this with the Run Club? I don't know if we can mention the Run Club,
the Noe Valley Run Club.
The Noe Valley Run Club.
No, it was not. It was not. It was a couple of friends. It was actually Narayan and a good friend Nick from Tesla, and we would. This is another one of these habits. Actually, I was asking you because I wondered how you motivate yourself to exercise. Is it for yourself or is it for an event? And it sounds like if you've only done one half marathon, it's for yourself.
Yeah, I don't know, because my girlfriend said I couldn't beat her. And I couldn't. She trained a lot more.
Oh, wow. She smacked you.
She beat me. We in the last mile, we were running it next to each other. And then she said, no way. And she gave it everything.
Oh, I love that.
I was dying because I hadn't really trained.
Oh, I've never met her. I reckon maybe the 4 of us should get dinner sometime. This woman sounds fantastic. Okay, so that's freaking hilarious. I love that. But I'm the same. I train for myself. I run for myself. My motivation is I want to feel good, right? But I also know people who, like, I want to feel good, but that's a very logical thing. And I need to add a layer between I want to feel good and I have enough motivation to exercise. Yeah. And that motivation is I'm going to sign up for an event and I know it's going to really hurt.
Oh, absolutely. Absolutely.
Yeah. But for me, it's the routine. Actually, with these Tesla friends, it was I decided that every lunchtime I would run. And so I'd bring my kit, I'd put on my shoes, I could tap my friends on their shoulders, and they would often say, no, I'm not coming today or whatever, but I would always go. Yeah. And it was hot because it's in Palo Alto most of the time. It's 30-something degrees often. And I'd often do a 4-kilometer loop, which is only 2.5 miles, but it had it had 80, 90-something meters of elevation gain, so a couple of 100 feet of elevation gain up and over the hill. Yeah. Only took 25 minutes or something, 20 minutes. Or a 7K loop. But
what time of day did you do this? So you wake up and then go run? Lunchtime. Okay.
That was lunchtime.
That's a great time to do it. Yeah.
Just before you actually eat. Yeah. And that way, we got often like a decent crowd, like 7 of us sometimes and 3 of us others. But the routine, I love it. A good routine is so good for you.
Absolutely. Yeah. We're really just a bundle of habits, you know.
That's really all our brains
At the
are.
end of the day,
When do you exercise?
I've tried to do it in the morning. I like to exercise in the morning. I do think it sets me up. You know, you don't really need a coffee or something like that if you're exercising in the morning. And I think one of the motivators is like I am cramped so much of the day, and I feel sore in weird ways, and I'd rather have the exercise soreness than the cramped soreness. And it like fights against it, right? So like, especially if like I feel something in my spine, then I'm like, I'm going to go do rows or something like that. Or the next day, I'm going to go do some rowing. So like, I think that's a little bit of a motivator, but I don't know if I'm a habitual exerciser yet. I feel like even like I'm pretty socially motivated too. Like I went to the Don't Die conference and I see the content on Twitter and all the people talking about the CEOs who deadlift and stuff like that. Like that stuff gets to me. It gets into my head. And then I think, you know, what am I doing? You know, not exercising when everyone else is exercising.
Yeah.
So
it's a cool thing. Everyone's doing it. You know?
Everybody's doing it. I got to get in on this. So you've got this stack of papers here. I'm so curious.
So there are two projects that I wanted to show you that I've been following recently that I think are fantastic. Been at it for a little while. They're big projects. Have you ever come across the ThunderScope?
I have not. The ThunderScope.
Yeah. So this is let me just figure out how many of these are actually involved with the ThunderScope and not. I've only printed off the first 5 pages, but it roughly, it looks like this. It is a oscilloscope that runs over Thunderbolt. So USB 4, I think it is, or Thunderbolt 4. And USB
interesting.
4 protocol. And it's kind of like, you're familiar with the Saley logic analyzers, right?
Yeah. Oh, yeah, for sure. So these tiny, they're tiny, right?
Super small, yeah.
And you can plug them in and you can debug SPI lines, UART lines, etc.
They're the size of like a drink coaster, rounded edge, rectangle.
Yeah.
And they run over USB 3. And so they've got a couple of gigabits, whatever it comes out to, 5 gigabits or something.
They're kind of like a rare thing where people really good at software and hardware, they just for a moment, they intersected because the software is really nice for them for debugging.
That's the thing. They sell such good software.
Yeah.
Or, the software is included with it as long as you buy the device, which I also love. There's no subscriptions or nonsense.
Right.
But they're really software people, mostly. And that's why they've got this beautiful tool. And they've got great hardware too, but it's not like an RF engineer is going to go in there and be like, wow, you invented a new, no. It's like, it's great hardware, but it's not, it's sensible, shall we say.
Right. It's not a super patented design. Some incredible.
No. The ThunderScope, though, is similar. So conceptually similar. It's a box with, in this case, it does have the insane analog front end on it, right?
Oh.
And so actually, here's the insides of one of them. And then it also has a big FPGA, and it uses Thunderbolt 4 or PCI, which is basically just a PCI interface, to get all of that data out of some insanely fast ADCs and into your computer, basically using your... So do you know how a digital oscilloscope roughly works?
No. I mean, there's an ADC somewhere on an analog to digital converter, but other than that, I haven't thought about it.
Yeah. So between the BNC, the connector that you plug your probe into, there's an analog front end, I used the term before, which is it's basically just a little bit of analog cleaning up of the signal to get rid of artifacts that are too fast and very, very smooth. But too fast in this case is they typically have like a gigahertz bandwidth, or you get up to like 10 gig. So when I say too fast, I mean really, really too fast. You don't get aliasing, that type of thing. Voltage protection, current protection, all sorts of...
Oh, yeah, so much stuff because people will plug anything into an oscilloscope.
Exactly. You can look at 400 volts or something.
Have you ever walked up to an oscilloscope and it's got some tape on it that says like this probe is broken or whatever?
Do not lick.
Do not lick.
Yeah, like dangerous. The probe is broken. I've never come across that, which is actually a testament to how good this protective circuitry is.
Yeah.
And then, as you're saying, they have a super, super fast ADC. These are typically running in the hundreds of millions of mega samples per second. So hundreds of millions of samples per second. And then you have an FPGA typically, or perhaps sometimes an ASIC, but I've never actually seen or heard of one. And that FPGA's job is basically just take this enormous bus of data which comes out to gigabytes of data a second, right?
Yeah.
At 400 megasamples a second, and you might have a 12-bit ADC, which is a good one, granted, and then dump it into RAM as quick as you can, right? And so they might have tens of gigabytes of RAM. You might have 32 gig of RAM in a good scope, right? And what the observation with some of the Saley and the ThunderScope is that, well, actually, the throughput to your computer is now fast enough that we can use your computer's RAM, and then you can do all sorts of incredible analysis on that in post.
Right. So you're no longer limited by the kind of like RAM on the board, on that tiny thing. You can now go to the computer, send all the data there, and have the computer do the analysis.
Yeah, and do whatever you like. You
Yeah.
know, you can do it. You can do insane things like this, which is really cool, and it also reduces the cost of the device so dramatically, right? Like these ThunderScopes, I think they're about $1,000, but they are just this insane device. And they've also built a GPU accelerated. It's an NG OpenScope client, I believe the software is called.
Oh, wow.
So it's a GPU accelerated pipeline for all of that data, and you can basically, with a drag and drop pipelining interface, design, a trigger or a Fourier analysis on all of that torrent of data coming through. Yeah, right?
So it's like finally, it's almost like you get to build the oscilloscope you want, because these are features of an oscilloscope, but they might not work the way you want, or you can't tweak it or whatever. Now you can just do whatever you want with it.
You got 4 synchronous channels. You can use one as a trigger to do something with another. You can combine them.
Right.
I even saw it's so fast that one of the plots they had was a heat map of where the signal was, because if you wanted to draw the line the whole way, it would be cluttered. But if you just give it a heat map, you can kind of see what's going on. It's just some beautiful stuff that's awesome. You can't normally tweak on it. A fixed closed source scope. And so they're doing all of this as an open source project.
Wow, that's so interesting. So, so this is like the analog version of this sailing device, and the analog version is much harder. It's all being done open source, and then you can make your own oscilloscope. I mean, I would imagine a lot of people are probably gonna, because this is kind of like a board, probably a lot of people are gonna put this into a box.
Yeah, potentially.
And sell it.
So there's actually 2 of them. The one that you're looking at the moment for everyone at home, it's a PCI Express card. So this one is meant to go directly into a desktop computer.
Whoa, no way.
Yeah. So you can
Wow.
So you can put multiple of these in a desktop computer if you're going to build a standalone.
Oh, this is a game changer.
Right?
Okay, now I see the vision. So in your desktop, literally like you would plug in a graphics card.
Yes.
My desktop has all these slots, and I have one graphics card. What am I doing with those other slots? Now I can plug in an oscilloscope.
You can plug in a scope.
Wow.
And you can embed this in your test equipment. You could put multiple in and have like 16 channels on a desktop computer, and then you run it through a big graphics card to do all the processing live.
Oh my gosh, this is huge. This is going to destroy oscilloscopes.
as we know them. It's going to revolutionize them.
Yeah, it's like it's a debundling. Did you say these are different cards, or?
So there's one of them. This one is a PCI Express card, and this is it in the box.
So you can get it in a box, and
Granted,
then
it's not the nicest box in my opinion. So I hope someone makes a nicer box. But yes.
So how does this one connect? Does this one connect with USB? Oh no, Thunderbolt,
which it runs over a USB-C cable. Exactly.
Okay, gotcha. Why Thunderbolt?
So Thunderbolt is just basically guaranteed highest spec possible of the USB spec.
Oh, and because Thunderbolt is kind of an open standard. I think that's not well known. People think it's an Apple thing, or am I wrong?
Yeah, no, it's not just Apple. Apple, like actually USB-C, were the biggest contributor or the biggest investor. They were huge in the development of it.
Yeah, they get a bad rap. People are like, oh, Thunderbolt, it's a proprietary connector. And it's kind of an open connector, actually.
So old Thunderbolt was a connector. New Thunderbolt, and granted, yes, it was just very aptly back in those days. New Thunderbolt runs over USB-C cables and connectors and everything.
Okay.
And is fully compatible with USB-C. It is just the highest spec version of USB-C as a guarantee.
Gotcha. So Thunderbolt actually means something different now.
Yeah, exactly.
Okay, hence my confusion.
Thank God.
Okay, so Thunderbolt is a good open standard now.
Yeah.
Who knows what it was before? Doesn't matter.
We don't need to look back then.
But if you see a Thunderbolt connector, but I'm guessing, just from my knowledge of Thunderbolt, which is very little, but I'm guessing it does. Is it the highest for power delivery too? Because those are tiny little pads.
It's a good question, actually. I don't know how it can do as far as power goes.
Yeah.
If you can simultaneously do USB PD as well as full speed Thunderbolt, I'm not sure. Because Thunderbolt is basically just a PCI lane directly over your USB cable, which is why these are so compatible with one another, is they basically just pin mux it onto a USB-C cable.
Oh, I see. Yeah, this is so cool. I will definitely be getting one of these.
Yeah. And the other really awesome thing is if you look at this design, right? So just for everyone listening, there's a little power supply, there's a FPGA underneath a heatsink, and then there are these 4 of these analog front ends, and they're each in a little aluminium or enclosure in order to basically shield them from one another.
Right.
It's all such high speed and high signal integrity stuff. And then there's 4 B and C connectors on the front. Because this is all open source, these little analog front ends are, practically speaking, the really hard bit, That's like, there's a lot of tweaking and like prototype revisions and a lot of stuff to get that right. The FPGA is an FPGA, but in a year's time, there's going to be better ones. You might want to build an ASIC, all sorts of stuff like that. You can imagine how much cool stuff you could do with just this little box as a design module, right?
We got to pull an image up for people on this one. To Naz.
Yeah, to Naz, please. ThunderScope. We'll shoot something your way. Note to the editor.
This is so cool, though. So these little, basically each BNC connector, as you were saying, it has a little box in front of it that has
dedicated front end.
Dedicated front end, very optimized analog circuitry.
Yes.
So it's kind of interesting because we're both building ways to kind of have modules for things. If somebody needs a component of an oscilloscope in the design, that is a perfect module to take.
Exactly.
Right.
You could imagine embedding basically a scope onto, let's say you're going to build a hill setup, for example. You could just embed part of the scope onto there, right? You have the design.
Yeah. I think probably the biggest thing would, maybe this, I think this is generally a good category for electronics as code. And I know JITX has, people use it for this, and Quilter, people use it for this, but just lab fixtures. Like instead of having somebody hook up an oscilloscope, which, it's okay. You kind of like, you have like a fixture and a fixture. You can just have one board that literally has everything. There's a oscilloscope on the test board. Yeah, exactly. Put it, Standardize everything.
Standardize everything. It just goes into one new server rack, and then you have your whole hill setups for every product in your company.
Absolutely. Okay, so one other thing, this is bringing up thoughts to me. I saw some really cool PCB and aluminum extrusion integrations on Twitter over the weekend. People were like, not just for shielding, but for heat dissipation. And that's what this one is for on the FPGA. That's for heat.
That's
right?
a heatsink, yeah.
But these ones are probably shielding.
Yes.
And aluminum is good for shielding, I think. Is that right?
Often they use, I think it's nickel-plated aluminum.
Okay.
Because that way they can solder the cap into place. And
Gotcha.
that way it's just like a component for the board. Yeah.
Gotcha. Okay, so this is kind of an interesting thing. I was thinking about how tooling today is integrated with these aluminum kind of or custom aluminum things that you might put on a board. I feel like there's not a lot of integration there. Like it's a separate part. There's like this phase of like mechanical PCB integration that's not super.
It usually sucks.
Yeah, it usually sucks a little bit. Like you're going to export your PCB into a 3D tool. And then none of that's going to be very automated.
No. The one group that does it well right now is the Fusion Eagle integration.
Yeah.
You can do some pretty nice stuff there.
Absolutely.
We've done flex PCBs actually, and you wrap them around your design and all sorts of stuff. It's so cool.
I think flex PCBs are where that's going to become top of mind for people, because flex PCBs enable so many cool form factors. There's a company, I think it's called Pillbot.
Okay.
Have you seen these guys?
Maybe.
What they do is they give you a pill that you swallow, and it gives you a colonoscopy, I want to say.
Is this the one it's got propellers and you can drive it around?
Yeah, you can drive it.
I saw this at Open Source.
Yeah. They were at Open Source. They were also at, I believe they were at Don't Die too, and a lot of people were like, let me swallow.
Can I eat it? Not this one, it's not sealed.
But and it's disposable, so you it goes through you, and then you throw it out.
You wouldn't want to just wash it. That's gross.
And then eat it again. Oh God! And also charge like the battery, everything about. But how it works is they have a flex PCB and they just fold it on top of itself. I think it's got like 4 layers like that, and they can use that space to have components, but also shove a battery in between the flex PCB spaces.
There's wild density out of it.
So there's so many cool architectures that flexible PCBs enable, and I think that's where you start to see those mechanical issues. I think, and I could be wrong, Altium is the only software solution that does this really well today. I'm sorry, not Altium, Fusion. Sorry, what we were just talking about. Fusion, it seems like it just kind of comes from actually, Altium might do this pretty well too. I don't know. Do you have any experience with this?
I know how I've seen it done, and I've seen it done where people will open their CAD software and export a DXF of the flat pattern of, like, they might use
and they do it in the 3D tool.
They'll do it in the 3D tool. They'll make the form factor of PCB they want, perhaps even using the sheet metal tools.
Yeah.
And then export the flat pattern of that, because it's already got all the fold and radiusing and all that type of built into your CAD sheet metal tool set. And then you just take that DXF and you plonk it into Altium or whatever. And then, so that's the workflow I've seen done professionally before.
That's interesting. It is similar to sheet metal mechanical modeling, I guess, to a large extent. Yeah. That's pretty interesting. I can't wait to see PCB mechanical, like, integrations and how that works.
Yeah.
Mechanical CAD, we kind of had to scrap this episode, but we had an episode where we were talking about code as CAD forever ago. And we had some guests and some audio issues. But it's such an interesting space.
Yeah.
There's new companies popping up all the time. Make with Atom is a company I just investigated the other day to see if it could generate 3D models for electronic chips automatically. And it did kind of okay. So, like, anyway, very interesting space. I have no idea what's going to happen.
Would you like to see the second thing I brought for you today?
Sure, let's do
it. This is a Pi MX8 module, as the project is called. It is basically a Raspberry Pi compute module, compatible, basically. And it's really cool. So I believe it's pin compatible and size compatible and everything with a Raspberry Pi CM4 compute, the exact same form factor. So it's tiny. It's also pretty powerful. It's a quad-core A53, 1.8 gigahertz, plus a real-time M7 core at 700 meg with a bunch of DDR4 RAM, a GPU, and you can add one of the Google... what are the Google accelerators called again? The accelerator
Tensor or something, maybe?
The Coral Edge. There you go. The
Coral
TPU.
Edge.
Yeah, have you come across this chip?
No. Coral Edge. I haven't heard of that.
It's the Google Coral is a edge compute TPU accelerator, basically. And I think it can function over USB or PCIe, if I remember correctly. And you can try to chuck it on at the edge of, whatever. You can sling it on the side of a Raspberry Pi, or in this case, they're using a... which CPU is it? The MX8 is... Oh, I'm blanking on this so hard. It's NXP's, obviously. It's NXP's line of Linux chips. And so they hang it off the side of this, and it's just an accelerator. So you can imagine, and you can see... Have you got the one of the enclosure there as well? You can see how tightly you can integrate this into something like, for example, a industrial camera, because it's tiny. The thing is only...
Oh, that's so cool.
The size of a credit card.
This is right up my alley, because I have wanted for the longest time cameras that do not output video data. They just output annotations, because I think it's way better for privacy. Like, let's say you want to you don't want to record people, but you do want to know if somebody is vandalizing a wall. So you just ask the camera, is there vandalization? I'm going to sound the alarm. Yeah. And then you don't have to record everybody who walks by or something like that.
Yeah. It's also incredible compression, right?
Yeah.
Like, you could use something like a LoRa radio, which only gets... 9,600 baud rather than
right, exactly. You can basically send out a binary signal. You can use exactly. So one thing I would love to investigate, I'll have to look for this, but how much power in a camera is spent for the camera, the processing of the image, because there's compression usually on a camera, I think, and then actually sending the data to the Wi-Fi chip, stuff like that, because with TPUs now, you can try to play with these ratios, right? Assuming the TPU isn't too power hungry, which I'm not sure. This is so cool.
It's basically replacing the compressor in that analog, because it takes the raw data. You don't bother to compress it before you give it to it. Yeah, that's an interesting one, isn't it?
Yeah.
And instead of compressing it to a video like 264 codec or 263, whatever it is, you end up compressing it to binary or bounding boxes or whatever you like.
Yeah.
Wow.
Just like where are the people in the room too? That's another.
Yeah.
When I was at Rensselaer Polytechnic Institute in the Lighting Research Center, they were doing a lot of work to have cameras send back infrared data, just like heat maps of a room. And the reason was because of privacy. So that's like, now that seems like a really over-engineered solution.
Yeah.
Like the camera is still there. People still know they're being recorded, but their faces aren't seen very well. But in my mind, that's crazy now. Like, I think we should just pre-process the data, and then cameras should be almost marked. I would love if cameras were marked privacy sensitive and just didn't record the specific things.
That's interesting.
You don't need to.
No.
Most of the time.
It reminds me a little bit of the airport scanners, of like how, with the super high resolution, whatever they are. They're not X-rays, but millimeter wave, something like that.
Right.
You're standing there, you got your hands up, and then it goes boop, boop, and then I'm sure somewhere in the computer there is just like an image of you 3D naked model standing there.
And they're like, hey, you're pregnant, right? Like because they can literally find stuff from those scans.
Yeah. They would maybe no, I've got no idea actually. I wonder, but the image, and you see what the image is because you step out and then the two guards, well not guards, TSA agents, and you look at the same thing and it's just a giant screen with a green checkbox and it's like, no worries.
Right.
And so they've done this type of compression of yay, nay, or yay, or look on the left hip kind of deal in order to, I guess, preserve privacy was a thing.
Yeah, absolutely. Yeah, so it makes a lot of sense. We should be doing this compression basically everywhere for those purposes. And then, cameras everywhere isn't as big of a concern. I would love, I'm no regulation guy, but if cameras had an indicator that said, hey, this is full video or this is, whatever, if there was some way to make that disclosure, that'd be great. Because so my last company, Seam, we would service a lot of people who ran Airbnbs. And you have smart locks on the Airbnbs.
Yep.
And Airbnbs are ripe for abuse.
Yeah.
You have a lot of strangers going into a home. You have so many different people. It's hard to pinpoint it. You are not allowed to have cameras in an Airbnb. It's an Airbnb rule.
Makes sense.
So hosts
do hide them at least.
All of the But hosts do all these tricks, including there's a company called NoiseAware, and it is a small device that reports noise and noise levels and then sends you alerts to know if somebody's throwing a party. So you literally, without a camera, it's actually hard to know if somebody's throwing a party at your house and has 30 people in the room. Yeah. Right?
Are you allowed to have an external camera or is it just internal?
I'm not sure you're allowed to have any cameras.
Interesting.
Yeah.
That's great to know next time I rent an Airbnb.
I mean, who knows? Because in the case you would bring up where somebody would expose the fact that they have a camera, it'd probably be something pretty bad, is my guess. So probably a lot of people have it. But I wish there was a gradient on these things because everybody wins. Airbnb prices go down if hosts do not have to kind of pay this insurance price for the few bad actors.
Yes.
Right?
Yeah. We all pay the insurance price.
We all pay that insurance price. The cleaning fees, right? Part of that is because some Airbnb guests make a huge mess. They are getting an Airbnb to throw a party.
Yeah, people suck,
People suck, And what they do is the lists for the requirements for what you cannot do in the Airbnb just grows and grows.
It just gets obscene.
Everybody's breaking the rule at some point. You can't have more than 5 people or whatever.
Yeah. And like, I guess the other thing is it's a dumb rule. Like, who gives a shit if you put 100 people in there if you're all having, a fancy cocktail party and you clean up perfectly afterwards?
If I'm just having my standard eyes wide shut mask, party, like, who cares?
But if I conversely, have a rager and throw the couch out the window, big problem. You know, that matters. So the 5 people isn't even, it's the best rule they can make with the information they have.
Exactly. Yeah. Exactly. Just so that everybody's kind of in the red.
Yeah. Incredible.
With that.
Thank you very much.
Yes. Thanks, Matt.
Thank you, Seve. Enjoyed it as always.
Great papers.
See you next time.
See you next time.